All right, 6.1b, we are now working with differential equations and looking at the application of slope fields. It's a field of slope. All right, so slope fields, it's a graphical approach to solving differential equations. We're just basically playing connect the dots, in other words. So the derivative of some function y will be a function of x and y. It could just have x's, it could have y's, it could have x's and y's, who knows? But it'll be some sort of expression that has x's and y's, or could have them. And at each point in the xy plane, a short line segment is drawn. Where's my pen? Drawn, there we go, showing the slope of the function at the point. Each line segment has the same slope as the solution curve through that point. All right, so let's see if we can do this. So sketch a slope field for the differential equation y prime equals x minus y at each one of these points. So here's our axis right here. So if I want to try at the point negative 1, 1, so then y prime would be x is negative 1 minus y, which is 1, which gives me negative 2. So at the point negative 1, 1, our slope is negative 2. So we're going to be going down like that. All right, next we'll look at the point 0, 1. And maybe I'll do a different color for each one. So y prime will be, let's see, it's x minus y. So 0 minus 1 is negative 1. So at the point 0, 1, so over 0 up 1 at this point, my slope is now negative 1. It's not quite as steep. All right, now we try another point. Say 1, 1. So y prime would be x is 1, y is also 1, we get 0. So at the point 1, 1, our slope is 0, so it should be a flat line. Next, let's see, what colors do I have left? Dark blue, sure. So next up, we've got negative 1, 2. So y prime would be negative 1 minus 2 is negative 3. So negative 1, 2 is up here, and our slope is even more steep going down. It's tough to show it more steep than with these small graphs, but that's what it is. All right, we've already done purple. How about red? 0, 2. Y prime would be 0 minus 2 is negative 2, which I believe is the same as that slope. And let's see, what else do I got? Darker red, sure. 1, 2. Y prime would then be 1 minus 2 is negative 1. So 1, 2, slope's negative 1, like that. All right, so if you notice, we're making a bunch of lines. Like if we pick some other points, like we can just pick any other points. We want like 3, 1 will give us a slope of 2. So we go over 1, 2, 3, up 1. We've got a slope here of positive 2. And if we wanted to do 2, 1, y prime, not y, y prime. 2 minus 1 would be 1, so we get a slope of positive 1 here, and then it'd be like positive 4 here, and this would be even steeper over here, and so on. We could go back down like 0, 1, or sorry, 1, 0, I guess that would be. It'd be here. Be positive going up like that. If we wanted to do the point 0, 0, we'd get 0, and that'd be flat like that, and so on. Like we can draw in all the different slopes at all the points we want, any point we want, and that'll give us the slope of the derivative. All right, and then what happens if we get a slope field? So this is like a completely different slope field over here. But say we wanted to start at this point right here. So we want to start at 0, 1. Like if we know that is part of our solution. All right, well, this line's going up. Oh, we hit that line. It kind of sends us over, and then this one sends us down, and then that sends us down, and that sends us back up like that. We just kind of follow the slopes. This sends us down until we hit that one. That sends us back up. Oh, that's going to kind of curl us back down. All right, this looks like a sine graph, right? All right, but we could just get a rough sketch of the solution that goes through this point. If we started at another point, we'd get a different solution. So like say we started at, I don't know, let's try 1, negative 2 and see what happens. Over 1, down 2, right there. All right, so this says my slope is going down, and then these guys say my slope's going back up. This says my slope is going this way. Nope. It kind of looks like it's going to turn back down here, and then back up here, and then back down here. But yeah, it's just a rough sketch. All right, so that's about what it's going to do. And again, it looks kind of like a sine curve. All right, so now can we match the differential equations with each of these slope fields? All right, so the trick is just to pick some points where they have different slopes. Like if I tried to pick the point 0, 0, looks like they all have the same slope there, the slope of 0. But if I pick the point 1, 0, well, those two have the same slope, but this one's different. So if I just look at the point 1, 0, let's see what happens with this guy. Y prime would be 1 minus 0 is 1. This guy would be y prime equals 1, just 1. This guy would be y prime equals 0. Aha, this guy has a slope of 0. He's going to look like this. And only one of them had that there, right that. So these two must go together. All right, we can try other points if we want, but it looks like that, yeah. Like if we tried 0, 1, it's going up, y would be 1. 0, 2, it's getting steeper, the slope here is 2. Everywhere that y was 0, it has a slope of 0. So yep, this guy definitely matches with that one. All right, so now, let's see, we tried 1, 0, it didn't work. What if we go up? Let's see, this one has a slope that looks like positive. This one has a slope that's flat. So what if I try the point, I'll change colors here, 0, 1, just a different point. So y prime here would be 0 plus 1. I shouldn't have subtracted there, but there we go. We get 1. And this one, x is just, again, we're trying 0, so it's just 0. So this one should be flat. This one should have a slope of 1. So if we look, here's flat. So that's this one. And this one should have a slope of 1. Yep, that's this guy. All right, because that has this little slope going up. All right, so that's how you can match slope fields. Oftentimes it's just good to just look at like a line, like one of the axes. And if the axes don't work, you just pick some other points like 1, 1, or just go straight up and down from 1. Like these guys, they're all the same slope at x equals 1. So that means the y must not be part of the equation. And if you look over here, all the same slope at x equals 1, the y is not part of the equation. This one's the same kind of thing. If you look here, like if you pick any y value, it's the same slope all the way across. Like right through here, same slope, every guy there with y equals 1. So that means the equation probably doesn't have an x in it. All right, and if you look, yep, the equation doesn't have an x. But if we look at this guy, if you go in any direction, like y equals 1, they're changing. If you look at just x equals 1, again, the slope is changing. So that means it probably depends on both x and y, and it does. All right, so that's a little bit about slope fields. We'll look at them some more later, but hopefully they're not too difficult.